You know what a Tyrannosaurus rex looks like. Everyone does. It's the most famous animal that has ever lived. Big head, tiny arms, massive jaws, rows of exposed teeth, scaly reptilian skin, gray or green or brown, a thundering roar that shakes the ground. You've seen it in movies, in museums, in books, on t-shirts and lunchboxes and children's toys. The image is burned into the global consciousness. You could draw it from memory. Almost everything about that image is wrong. The skin was probably not entirely scaly. Evidence suggests at least partial feathery covering. The teeth were almost certainly not exposed. A 2023 study in Science demonstrated that theropod dinosaurs, including T-Rex, most likely had lips. The roar didn't happen. The vocal anatomy of archosaurs doesn't support mammalian-style roaring, and the overall body shape, that lean, muscular, shrink-wrapped look, is almost certainly a product of artistic convention, not anatomical reality. The T-Rex, you know, is not a scientific reconstruction. It's a cultural icon, built layer by layer over decades of movies, illustrations, and museum exhibits, each one copying the last, each one carrying forward the same errors, because changing them would mean admitting that the old version was wrong. This happens with every prehistoric animal, not just T-Rex, every dinosaur, every marine reptile, every Ice Age mammal, every creature on every slide of every video on this channel. None of them are photographs. All of them are interpretations. And interpretations are only as good as the assumptions they're built on. Today, we're going to look at those assumptions, and we're going to break them. The single most common error in paleoart has a name. It's called shrink wrapping. And once you see it, you can't unsee it. Here's what happens. A paleontologist discovers a fossil. They clean the bones, measure them, describe them, and publish a paper. An artist reads the paper and creates a reconstruction, a painting or a 3D model of what the animal might have looked like in life. But here's the problem. The fossil is just bones, maybe some teeth, maybe a partial skull, almost never any soft tissue, because soft tissue rots. So the artist does the simplest thing possible. They take the skeleton and wrap skin directly onto it, tightly, following every curve of every bone. The result is an animal where you can see the shape of every vertebra through the skin, where the eye sockets are clearly visible, where the skull looks like a skull with a thin layer of paint on it. This is shrink wrapping, and it produces animals that look skeletal, gaunt, and monstrous, because they literally are skeletons with skin stretched over them. The problem is obvious when you apply the same technique to animals we can actually see. Take a hippopotamus. A hipposkeleton looks absolutely nothing like a living hippo. The skull is massive, enormous jaws, huge tusks, eye sockets positioned high and far apart. The ribcage is barrel-shaped. The legs are thick, columnar bones. If you shrink-wrapped a hippo, stretch skin tight over the skeleton with no fat, no muscle bulk, no soft tissue, you'd get something that looks like a demonic, snarling predator. Sunken eyes, visible bone structure, exposed tusks, a nightmare. The real animal is round, soft, blubbery. Its ears are tiny and cute. Its nostrils are fleshy bumps. Its body is a smooth, barrel-shaped mass of fat and muscle that bears almost no visual relationship to the skeleton underneath. A swan. Take the skeleton of a swan and shrink-wrap it. You'd get a long, serpentine neck, bony, articulated, reptilian, a flat, hooked beak, clawed feet, no indication of feathers, of fluffiness, of grace. You'd reconstruct a small dinosaur. You'd never in a million years guess that this animal was a white, elegant bird with a thick layer of down and contour feathers that completely transforms its silhouette. A baboon. The skull of a baboon has enormous canine teeth, longer, relative to skull size, than a lion's. If you shrink-wrapped a baboon, you'd create something terrifying. A sharp-faced, fang-bearing predator with deep-set eyes and prominent bone ridges. The real animal is fuzzy, with cheek pouches, and a pink face, and a fluffy mane. This is the fundamental problem. We cannot accurately reconstruct the external appearance of a living animal from its skeleton alone. It is physically impossible. Too much information is lost. The skin, the fat, the cartilage, the keratinous structures, lips, nose pads, ear pinny, wattles, dewlaps, crests, none of these fossilize, and all of them dramatically change how an animal looks. If we can't do it for a hippo, an animal we can look at, what makes us think we can do it for an animal that's been dead for 66 million years? Every dinosaur reconstruction you've ever seen is shrink-wrapped to some degree. The skull is too visible. The body is too lean. The soft tissue is too thin. Because the artist only had bones, and bones are all they drew. In 1993, Steven Spielberg released Jurassic Park. The dinosaurs were scaly, reptilian, leathery. They looked like giant lizards, which is exactly what most people, including many scientists, assumed dinosaurs were. 3 years later, in 1996, a fossil was found in Liaoning Province, China, that quietly detonated everything. Sinosauropteryx prima, a small theropod dinosaur, about the size of a turkey, preserved in fine-grained volcanic ash with enough detail to show the outline of its body covering. Feathers, not flight feathers, not the structured aerodynamic feathers of modern birds. Simple, filamentous structures, proto-feathers, like fur almost, a fuzzy coat covering the animal's body and tail. This was the first non-avian dinosaur confirmed to have feathers, and it was a theropod, the same group that includes Velociraptor, Allosaurus, and Tyrannosaurus rex. The implications were immediate and unsettling. If this small theropod had feathers, what about its relatives? What about the larger theropods? What about the most famous theropod of all? Since 1996, the evidence has only grown. Dozens of feathered dinosaur species have been discovered, not just small ones. Yutyrannus huali, discovered in 2012 in China. A tyrannosauroid, a direct relative of T-Rex, 9 meters long, roughly 1,400 kilograms, and covered in filamentous feathers. The entire body, 9 meters of feathered predator, not a small bird-like thing, a large, heavy, powerful carnivore with a fluffy coat. So, did T-Rex have feathers? This is where it gets complicated. Skin impressions from adult T-Rex specimens, found in Montana and other sites, show scales, small, pebbly scales, similar to those found on modern reptile skin. These impressions come from specific body parts, the tail, the abdomen, the neck. So, scales. Case closed. T-Rex was scaly. Not necessarily. The skin impressions cover only a fraction of the body's total surface area. Large stretches, the back, the upper legs, the arms, are unknown, and modern animals routinely have mixed coverings. African elephants have sparse hair across their bodies and thick hair around the eyes, ears, and tail, while most of their skin appears bare. Vultures have feathered bodies and bald heads. The most likely scenario for adult T-Rex, mostly scaly, with possible feathery or filamentous coverings on parts of the body, not represented in the fossil record. Juveniles, almost certainly feathered, based on phylogenetic inference. Young T-Rex probably looked less like a tiny lizard and more like a large, fuzzy chick. A baby T-Rex, fluffy, downy, cute even. The cultural resistance to this idea is enormous. Jurassic Park and its sequels cemented the scaly image so deeply that feathered dinosaurs are still met with public discomfort. "That's not a real dinosaur," people say. "That looks like a chicken." Yes, because dinosaurs are closely related to chickens. That's not an insult. That's phylogenetics. The scaly reptilian T-Rex of popular culture is not a scientific reconstruction. It's a movie monster. A brilliantly designed, culturally iconic movie monster, but a movie monster nonetheless. The real animal had more in common with a bird than a lizard, and the sooner we accept that, the closer we get to the truth. In March 2023, a team led by Thomas Cullen published a paper in Science that, if the field of paleontology were a building, kicked down one of its longest-standing walls. The paper was titled, essentially, "Theropod dinosaurs had lips." Not thin, reptilian lips. Full, soft-tissue lips, like those of a monitor lizard, that covered the teeth completely when the mouth was closed. For decades, generations, every reconstruction of T-Rex, Allosaurus, Velociraptor, and every other theropod dinosaur had shown the teeth fully exposed, jutting out, visible at all times, like a crocodile. The image was iconic. The permanent snarl, the visible fangs, the death grin of the apex predator. And it was probably wrong. Here's the evidence. First, tooth enamel. Teeth that are permanently exposed to air, like crocodile teeth, show a specific pattern of wear. The enamel dries out. It cracks. It develops a distinctive surface texture that's different from teeth that are kept moist inside a closed mouth. Cullen's team examined the enamel of theropod teeth, including T-Rex, and found that the enamel was well preserved, smooth, uncracked, consistent with teeth that were protected from desiccation. In other words, something was covering those teeth, keeping them moist, keeping them intact. Lips. Second, tooth-to-skull ratio. In crocodilians, the primary model used for lipless dinosaur reconstructions, the teeth are enormous relative to the skull. They're so large that they physically cannot be contained inside the mouth. They have to stick out. The skull isn't big enough to hold them internally. In theropod dinosaurs, the ratio is different. The teeth, while large in absolute terms, are proportionally smaller relative to the skull, much closer to the ratio seen in monitor lizards and other lipped reptiles. The skull is big enough to contain the teeth. There's room for lips. Third, foramina patterns. Foramina are tiny holes in the bone where blood vessels and nerves pass through to supply soft tissue. The pattern of foramina on the jawbones of theropod dinosaurs doesn't match the pattern seen in crocodilians. It matches the pattern seen in lizards, specifically lizards with lips. The nerve and blood supply architecture of a T-Rex jaw looks like it was built to support a lip structure, not a crocodile-style exposed jawline. Cullen's conclusion was straightforward. Theropod dinosaurs, including T-Rex, had lips. When the mouth was closed, you could not see the teeth at all. Think about what that means for every T-Rex model in every museum on Earth, every illustration in every book, every frame of every Jurassic Park film. The signature image, the permanently visible teeth, the menacing grin, is wrong. A closed-mouthed T-Rex didn't look threatening. It looked, and I'm not being dismissive here, this is genuinely what the science suggests, more like a very large, very serious bird, with a closed mouth and a neutral expression. Not scary. Wrong. A Komodo dragon has lips. A Komodo dragon keeps its teeth hidden when its mouth is closed. A Komodo dragon looks, when its mouth is shut, like a big, placid, slightly grumpy lizard. A Komodo dragon is one of the most terrifying predators alive. Lips don't make something less dangerous. They just make it look different from what you expected. What color was a Tyrannosaurus Rex? If you've seen any reconstruction, any movie, any painting, any museum model, you've seen a color. Green, brown, gray, dark olive, sandy beige. Sometimes, in more creative reconstructions, dark red or mottled patterns. All of them are made up, every single one. For most of the history of paleontology, we had zero evidence for the coloration of any dinosaur, not one scrap of data. Every color choice in every reconstruction was the artist's invention, sometimes based on educated guesses about habitat and camouflage, sometimes based on, "this looks cool," and sometimes based on nothing at all. The convention of gray, green, brown dinosaurs isn't scientific, it's tradition. One artist painted a dinosaur greenish-brown in the 1920s because lizards are greenish-brown, and every artist after that copied the palette for nearly a century. But starting in 2008, that began to change. Jacob Vinther, a paleontologist at the University of Bristol, realized that microscopic structures preserved in some exceptional fossils weren't bacteria, as had been assumed, but melanosomes, organelles that, in living animals, contain melanin pigment and determine color. Different shapes of melanosomes produce different colors. Round melanosomes, called eumelanosomes, produce black and dark brown. Elongated melanosomes, called phaeomelanosomes, produce reddish-brown and ginger tones. By mapping the shape, size, and distribution of preserved melanosomes in fossil feathers and skin, scientists could, for the first time, determine the actual color of an extinct animal. In 2010, Sinosauropteryx, the same feathered theropod from China. Its melanosomes revealed a ginger and white color scheme, with a striped tail, like a lemur, a striped tail dinosaur, not gray, not green, orange and white, with stripes. In 2012, Microraptor, a small, four-winged dromaeosaur, a relative of Velociraptor. Its melanosomes match those found in modern crows and starlings. The color, iridescent black, glossy, shimmering, like an oil slick in sunlight, a dinosaur that looked like a crow, with four wings, covered in glossy black feathers that shifted color in the light. In 2016, Psittacosaurus, a ceratopsian, a relative of Triceratops, not a theropod, a beaked, plant-eating dinosaur about the size of a large dog. Researchers mapped its melanosomes and determined it had countershading, dark on top, light on the belly. The same pattern used by modern deer, antelope, and fish. But they went further. By modeling how countershading interacts with different light environments, they determined that Psittacosaurus's specific shade pattern was optimized for a forested environment. Dappled light filtering through a canopy. Not open plains. Forest. Color told us where it lived. A melanin pattern in a 120 million-year-old fossil revealed the habitat of an extinct animal. But here's the limitation. This technique only works on fossils with exceptionally preserved melanosomes, typically small animals in fine-grained sediment. Large dinosaurs, T-Rex, Triceratops, Brachiosaurus, have never yielded melanosomes. Their skin preservation is too coarse. So the biggest, most famous dinosaurs, we still don't know what color they were. Every image you've seen is a guess. An educated guess sometimes, based on body size, likely habitat, and analogies with modern large animals. But a guess. The green T-Rex is a guess. The brown Triceratops is a guess. The gray Brachiosaurus is a guess. And some of those guesses might be spectacularly wrong. For all we know, T-Rex was bright blue. We have no evidence to say otherwise. One more thing, and this one might bother you the most. The roar, the thundering, ground-shaking, eardrum-rattling roar of the Tyrannosaurus Rex. You've heard it in every movie, every documentary, every theme park ride. It's one of the most recognizable sounds in cinema history. The T-Rex roar from Jurassic Park was actually made by combining the sounds of a baby elephant, a tiger, and an alligator. It is, almost certainly, fiction. Roaring, the deep, resonant, open-mouthed vocalization made by lions, bears, and some primates, requires a specific type of vocal anatomy. A larynx with well-developed vocal folds, a throat structure that allows air to be forced over those folds at high pressure to produce a sustained, loud, tonal sound. T-Rex was an archosaur. Its closest living relatives are birds and crocodilians. Birds have a syrinx, a vocal organ located at the base of the trachea, unique to birds. It can produce an enormous range of sounds. But the syrinx evolved in more derived bird lineages. The common ancestor of birds and non-avian dinosaurs almost certainly did not have one. Crocodilians vocalize differently. They produce low-frequency sounds, bellows, rumbles, hisses, using a combination of throat vibration and closed-mouth vocalization. When a large alligator bellows, it produces infrasound, frequencies so low that the human ear can barely detect them. The sound is felt more than heard. The water on the alligator's back visibly vibrates, a phenomenon called the water dance. T-Rex almost certainly could not roar. What it could do, based on the anatomy of related animals and the physics of its skull and throat, was produce closed-mouth vocalizations, low-frequency rumbles, infrasonic booms, sounds that you would feel in your chest before you heard them with your ears. Imagine standing 50 meters from a 9-ton animal. It doesn't open its mouth. It doesn't snarl. It doesn't scream. It hums. A deep, subsonic vibration that resonates through the ground and through your ribcage. You don't hear it coming. You feel it. In your bones. In your stomach. A pressure wave that makes the air feel thick. Honestly, that's more terrifying than a roar. A roar you can locate. A roar tells you where the danger is. Infrasound is directionless. It's everywhere. You feel it before you know what's making it. But it doesn't look cool in a movie. So we got the roar instead. In 2012, 3 paleo artists and scientists, John Conway, C.M. Koseman, and Darren Naish, published a small book that fundamentally changed how the paleontology community thinks about Reconstruction. The book was called All Yesterdays: Unique and Speculative Views of Dinosaurs and Other Prehistoric Animals. The premise was simple and devastating. The first half of the book presented speculative but scientifically plausible reconstructions of known dinosaurs, but drawn in ways no one had seen before. Dinosaurs sleeping, dinosaurs playing, dinosaurs covered in fat, dinosaurs with wattles, dewlaps, inflatable throat sacs, soft tissue structures that no fossil would ever preserve, but that are extremely common in modern animals. A stegosaurus covered in a thick layer of fat, looking less like an armored tank and more like a rotund, pig-like animal. Scientifically plausible, we have no idea how much fat Stegosaurus carried, and many modern herbivores are extremely round. A Leolinosaura, a small polar dinosaur, covered in thick, fluffy plumage, like an owl, living in darkness for months during the Antarctic winter. Scientifically plausible, a polar dinosaur almost certainly needed serious insulation. A Majungasaurus, a large theropod, shown with a thick layer of soft tissue over the skull, giving it a rounded, almost dog-like face. Not the typical bone-faced monster, an animal that looked like an animal. The second half of the book was the masterstroke. Titled All Today's, it showed what would happen if future paleontologists, millions of years from now, reconstructed modern animals using the same methods we use for dinosaurs. A cat, reconstructed from skeleton alone, became a lipless, hairless predator, with enormous exposed fangs and bulging eyes. A terrifying alien. An elephant, shrink-wrapped over its skeleton, became a gaunt, bony creature with tusks jutting outward and ears reduced to tiny flaps. Unrecognizable. A swan, stripped of feathers and fat, became a long-necked reptile with clawed feet and a hooked beak. A pterosaur, almost. A manatee, a gentle, round, blubbery marine mammal, became a sleek, hydrodynamic predator when reconstructed from bones alone. Because manatee bones looked nothing like a manatee. The message was clear, and it was brutal. If we can't reconstruct a cat from its skeleton, and we can't, then every reconstruction of every dinosaur is, at best, an educated guess, and at worst, a culturally inherited error that nobody questions, because everyone copies the same template. All yesterdays didn't just critique paleoart. It forced the entire field to confront an uncomfortable truth. We don't know what these animals look like. We have clues. We have data. We have increasingly sophisticated tools. But we don't know. After 2012, paleoart began to shift. Slowly. New reconstructions showed dinosaurs with more soft tissue, more fat, more plumage, more color, more life. But the old images persist, in movies, in museums, in the public imagination. Jurassic Park's T-Rex, scaly, shrink-wrapped, lipless, roaring, is still what 90% of people picture when they hear the word dinosaur. The gap between what science knows and what culture shows has never been wider. Here's what all of this comes down to. Every creature we've discussed on this channel, every endoceras, every Tully monster, every terror bird, every anomalocaris, is a reconstruction, an interpretation, a best guess made by talented scientists and artists working with incomplete data. And those guesses are getting better. Every decade, new tools emerge. Melanosomes give us color. Biomechanical modeling gives us movement. CT scanning gives us internal anatomy. Protein analysis gives us evolutionary relationships. We're building a sharper picture of the past, one pixel at a time. But it's still a picture, not a photograph. And the difference matters. Because when you look at a museum exhibit and see a T-Rex with exposed teeth and scaly skin, you're not seeing science. You're seeing a tradition. A visual tradition that started with an artist's guess a century ago and has been copied, refined, and reinforced by every movie, book, and toy since then. The real T-Rex, the one that actually walked the Earth 67 million years ago, is still unknown to us. We know its bones. We know some of its skin texture. We know its bite force. We know its growth rate. We don't know what it looked like. Not really. Not completely. Not honestly. And that's okay. That's not a failure of science. That's the nature of looking backward in time through a record made of stone and absence. But it means we should hold every image of the past a little more loosely, a little more humbly. Every reconstruction is a hypothesis, not a fact. Every painting is a question, not an answer. Now, we've spent this video talking about what dinosaurs didn't look like, what they weren't. Next time, let's talk about what they were. Because there's a question that almost nobody asks, and the answer is far more interesting than the usual asteroid killed them story. The question is, why did dinosaurs dominate for 165 million years? Not how did they die? How did they live? What specific, measurable physical advantage did they have over every other land animal on Earth for 165 million consecutive years? There's an answer, and it's not size, it's not teeth, it's not aggression, it's something much simpler and much stranger. Until next time, stay curious, Stay terrified.